Hello everyone. In this video we will be talking about angles and triangles, something that I am very excited to talk to you about, seeing as how it is something new and something different, and it is basically your introduction into basic geometry. Something that is very fun in mathematics, it's very imaginative, and much closer to a puzzle than the traditional mathematics and calculations that you've known so far. So let's get started. We will be trying to answer the questions: what is an angle? How do I measure it? What types of angles are there? How do I use angles to define triangles? And what role do angles play in triangles? Let's get started with the first one. What is an angle? So you've heard about angles definitely before. We've talked about them many times in class, and you have probably heard them in your everyday life as well, but we've never really defined them specifically. So we used to say, for example, when we were doing basic shapes ever since year one, this is a square, right? And we used to say that a square has four equal angles. Well, this is an angle right here. This is an angle, this is an angle, and this is an angle. That's four equal angles. You can think about them like this. If this was a room of a house, then each corner is an angle. Okay? So the corners in your house, the corners that the walls make, for example, that's an angle. But in geometry, we don't say corners, we say angles. Okay? So an angle is created whenever two lines intersect, whenever they cross. So it doesn't have to be in specific lines. So here and here, just random like that. See, I didn't have to do anything specific. Now these lines crossing has created, we could say, four corners. They don't have to make exactly a cross like the ones that we saw before, but here they've made one corner here, one corner here, one corner that is here, and one corner that is here. Let's actually color them. How are we going to do that? We're going to bring these lines together. We are going to make a circle behind them, a big circle with its center at the point where they intersect. That wasn't it. There, that looks more like it. Okay. And then we are going to combine again. So our first angle is right here. Our second angle is this one. Our third angle is this one, and the last one I'm going to leave is green. So you can see 1, 2, 3, 4 angles. And the rest of the exercise, I'm not going to be making the angles so precisely. You might just see me doing this just to save a little bit of time. So if I do this instead of all of that, what I just did, that's the same thing. It just shows you that, oh, I'm talking about this angle right in here. So what is it basically? What is the angle? It's this opening. Basically, how wide is this opening that has been created by these two lines? Is it really wide? Is it big? Or is it small? So you can see that the red angle is quite small compared to, example, the blue and the green angles. And also the yellow is quite small compared to the blue and the green. So an angle shows me how big or small the opening between the two lines is. Now, it doesn't have to be specifically like this. I could, if I wanted to, rotate this line, turn it around like this, right? And now that you see that I've made this angle even smaller, it's even smaller now. It's even less open, and this one is even bigger. It's really big now. It's almost a straight line. And again, this one is small as well, and this one is big as well. So we saw that before. Let's see if we can make some more examples with angles. Let's see, for example, here. I'm going to make one line like this. And for the sake of simplicity, I'm not going to make lines that extend forever, that just continue on. Instead, I'm going to be making lines that meet at a specific point, and they have a beginning and an end. Whereas the previous lines that we made, it's sort of implied that they continue on forever. Whereas these lines, they have a specific length. So we have two lines here, and the point of intersection, the point where they meet, basically, is right here. So they make an angle. They make an angle right here. And you're seeing me make these almost circular shapes like this, because that's basically what the line is. It's let's put it this way. That's basically what the angle is. What the angle is this. If I had another line, see this line that I'm holding now and I'm moving it? Yeah, you see that? Now if I had this line and it was right here, where the angle begins, and I had to turn it almost like in a circular motion. It does seem like the hand of a clock, which is a circle, doesn't it? Moving around. And if I am moving it around like this, how far would I have to move it around to get to this upper line here? Right? That's the angle. If the other line was up until here, then I would have to make this motion, small angle. If the line was over here, then I would have to start from here and make all of this motion up until I reached it. So that's a big angle, right? That's what this little line, circular line, shows me. Okay? Okay, well, we have that. Let's say now that we have another one goes up to here. So I'm going to make this one blue. I'm not going to make it on top of the red so that you can tell them apart. I'm going to make it a little further ahead. And what you can tell is that the blue angle is greater than the red angle, because if I start from here and I start moving up until I meet it here, then this is further away. This angle is wider. This angle is bigger. I can make them even bigger though. How? I can take this angle and turn it all the way here. And I would have to start from here and get all the way over here. So let's make this one green. Wait, no. Let's start from here, go all the way around until I got here. So you can see now that the green angle is even bigger than the blue angle, and the red angle, of course. But do we have a way to make this more specific by saying how much bigger? Well, you see, angles are measured in degrees, and the tool that we use to measure degrees and basically angles is this one. This is called a protractor, and I'm absolutely sure that you've seen one before. You may even have one at home, If you don't have one at home, listen carefully, this is going to be important, you need to print one out. If you don't have one of these tools at home, you need to print one out so that you can use it for the exercises that we are going to do. Okay? So, how do I use this? Let's say I make a random angle. Let's say I go and make this. And I want to measure how open this angle is. Well, these two lines, they meet this point right here, right? Yeah. What I need to do is take my protractor and move it towards my angle and place it so that this spot, the center, is exactly on top of the point where the lines intersect. So that would be here-ish. Here. Okay. Once I've placed the protractor at the correct spot so that its center is at the point of intersection, I'm going to turn it. I'm going to start turning it. But okay, where do I turn it? Where exactly do I stop turning? Well, I stop turning so that one of the sides, either this side or this side of the protractor, touches one of the lines that create the angle. So let's see, we could do here. We could do here, because this side is touching, right? We could do here. There we go, because that side is touching. And we could do here. But with this, because this side is touching, with this case and this case, there is a problem. That the angle is not inside the protractor, and it needs to be inside the protractor, whereas here, the angle is inside it, okay? So there we go, now it's inside. Here, again, the angle will be inside, see? Whereas here, it's outside the protractor. I'm going to place it like this. And now this side is touching one of the lines. Great. Okay. Now what do I do? Initially you might get confused by the fact that there are two sets of numbers. So here you have 0, 10, 100, 20, 30, 40, so on. And then here you have the other way around. So 0, 10, 20, 30, 40, and so on. And you might think, okay, well, which one do I need to use? Well, let's look at this again. I'm going to make a line. And imagine that this is the hand of a clock. I'm also going to make it red so that you can spot it. Okay. See the red line? Great. Gotta change that up a bit. Now, see how it's moving like the hand of a clock, right? And it's basically sweeping across the angle. Well, what I need to measure using this tool, my protractor, is how far does it need to sweep to get from one line to the other, right? Well, each of these one lines is what we call a degree, and angles are measured in degrees. Just like lengths are measured in centimeters and millimeters and all that, and your ruler has millimeters on it, so the protractor has degrees. So right here, where the red line is on top of the first line, that's 1 degree. Then 2 degrees, 3 degrees, 4, 5. And if I continue, that's 10 degrees. You counted with me, right? That's 10 little lines, 10 degrees. Well, if you look here, right here is 10. There you go, that's 10. Which makes sense if you think about it, because since we're starting to count from this line, as in this side, right, then it makes sense that I would start counting from the 0 and not the 180. So I would use the inner set of numbers. Now, we want to measure how much this is. So what we're going to do is say, well, since I'm starting on this side, and I'm going to start from the 0, I'm going to start counting from 0 to see where it goes. It's going to go 10, 20, 30, 40. Then if I go to 50, I pass it, so not 50. So we're going to go 45, 46, 47, 48. So this angle, I would say that this angle is 48 degrees. Got it? Great. Now, let's do another one. You might be asking yourself, okay, well, if it's like that, then why even have two sets of numbers? Let's see an example of why that is, why that even exists. I have this angle right here that I want to measure. And yes, both sides can be inclined. One of them doesn't necessarily have to be horizontal. So I take my protractor and I place it, so that its center is at the point where the two lines intersect. And I rotate it so that one of the lines touches one of the sides of the protractor, either this side or this side touches one of the lines. Now I could do this, so it touches here, or I could do this. But this looks kind of difficult because if you see the numbers here are upside down, it's a little confusing. So instead I'm going to put it like this. So now I have to start counting from the line that my protractor is touching, meaning this line right here. I'm not going to start counting from this side that we did before. And whereas before we started counting from the inner set of numbers, now the 0 is the outside. The 0 is on the outside set of numbers. So again, let's see which side. Okay, I'll make a copy of this, and then we'll make it red as well. Or green. Yeah, just make it green. And now what we want to measure is how many degrees is it to rotate from here, the beginning, 0, all the way to here. How many degrees is that? Well, let's see. we immediately see that we have 10, 20, 30, 40, 50, 60, 70, 80, 90. You could just go straight to the first number that's closest to it, but still behind it. You shouldn't go to 130. So we'd go to 120, right? And then we'd say 121, 122, 123, 124. So I would say that this angle is 124 degrees. So that's how I measure an angle. Really quickly, we're going to talk about how to create an angle of a specific length, and we are going to be practicing this next time. All of these things, basically. So let's say an exercise asks you to create an angle that is basically, let's say 75 degrees, okay? Well, what you do is you make one line wherever you want, unless it asks for something specific. You place the protractor down and use its bottom part as a ruler. So you start from here, from the center, and you pull a line that goes this way. Okay? The next step, we said we want 75 degrees, right? So what you're going to do is find 75 degrees starting from the intercept, because look, this line is touching this side, so we got to start from the 0 that's on this side. We want to find 75. So here, exactly 75. So here, you're going to use your pencil to put a dot right there. Actually, let's make that black since we started using black. You're going to put a dot with your pencil right there, because that's where 75 degrees are. Then you're going to move your protractor away. What you need to do now is unite this line with the beginning of this line. Now careful, you need to do it with the beginning. If you do it here, for example, that's not the same angle as this, for example. Right? So you need to unite this point with this starting of the line. And to do that, you have to use a ruler. So you could use the bottom part of the protractor. If you don't have a ruler, you can just turn it around. Go. Turn it like, sorry. Let's say you did not, let's say you were here where you just made the dot at the 75 degrees mark. And you want to make the line, okay, but you don't have a ruler. So instead of taking away the protractor, what you do is you turn it around so as to put the beginning of the line and the dot that you made on the same line, basically, and you draw a line there with your pencil or pen. And now what you have, if you turn back your protractor, what you're going to see is an angle of 75 degrees. Perfect. Now, we're going to talk very quickly about kinds of angles, types of angles. There are three basic types of angles. Oh, wait, I've made a mistake here. This is, yeah, sometimes you might get them confused. This is acute, this is obtuse. Okay, so there are basically three types of angles. There are the angles that go from 0 up almost to 90, but not 90, so up to 89. And those angles that are in here, in this range from 0 to almost 99, called acute. So angles that are less than 90 degrees. There's the angle that is exactly 90 degrees, the right angle. You've heard us talking about that a lot in the previous years. We were saying, for example, that squares have right angles and rectangles have right angles. What does that mean? We used to say that it's when two lines make a cross. That's not really the definition. The real definition is an angle that is 90 degrees. So take the protractor, place it here. And if I wanted to find the angle between this line and this line, you can see that it reaches 90 exactly. So that's a right angle, an angle that is exactly 90 degrees. Lastly, we have the angles that are more than 90. So angles that start from here, go all the way around like this. We saw one like this before when we measured it. I think we got 124 degrees or something close to that. And these angles that are more than 90 degrees are called obtuse. Now, something that I would like to point out, but before I do, last reminder, less than 90, acute. Exactly 90, right. More than 90, obtuse. Now, something I wanted to point out is this. Say I have two lines here. Here I have one straight line. But imagine that I took this line let's actually erase that for the time being. Imagine I took this line and I cut it in half. See? I made one part of it disappear. Now, you could say that these are actually two separate lines. And what I'm really doing is just pretending that they're one line. So I could turn this around and make it like this. They're two separate parts. But if I turn it back, I could turn it back, and now they make a straight line. Now, they're still two separate parts, though, right? Yes. So that means that they form an angle, that to go from this point all the way around to this point, that is an angle. Okay, well, how much is that angle? That angle is 180 degrees. You can see that if I start counting from this 0, I go all the way around to the other side, I get to 180. I start from this 0, go all the way around, I go to 180 again. So, what does that mean? Does that mean something? Well, yeah, that's why this point is very important, the 90-degree angle. It is the half of 180. And 180, if you pay close attention, you will see that the protractor looks like half of a circle. And if I want to, I could put two protractors together and I could make a whole circle. What would I get if I tried to start from this point and go all the way around and then back to the point that I started? Well, we said that from here to get to here, it's 180 degrees. And then from here to get to here, that's going to be another 180 degrees. In total, 360 degrees. That is how much it takes. That's how many degrees it takes to get around one full circle. 360 degrees. Half the circle is 180 degrees. And here, what we saw before, if I extend this a little further down, no, not this, what you can see is that I've basically cut this circle in 4 pieces. So the 90-degree point is 1/4 of the circle. This is 2/4 of the circle, 3/4 is going to be here, and 4/4 of the whole thing is going to be here. That's their importance, basically. Also, side note, you've probably heard people say the phrase, oh, he made a 180-degree turn. You've probably heard people saying that. What does that mean? That if someone was going this way, or saying they were going that way, they were heading that way, they turned around 180 degrees, and now they're heading this way, over that way. So they're heading back where they were coming from. We use this in language to show that someone changed their mind about something, that their opinion flipped and became the opposite of what it was. So you can remember it like that, that we say that making a 180-degree turn is basically going all the way across to the other side. But also keep in mind, because this is a mistake that many grown-ups make, is they say, oh, well, instead of saying the correct way, 180-degree turn, which is, again, starting from here, going all the way here, going the opposite way, they say, oh, he made a 360-degree turn because they remember that the circle has 360 degrees, and maybe they're a little confused about it. Maybe they don't remember exactly their geometry that they did in school, so they say 360 degrees. What does that mean? I went all the way, I was heading this way, right? And then I went all the way around the circle and ended up back where I was. So nothing changed, which is the opposite meaning of what the phrase intends to say. So be careful not to get that mixed up. Okay, that'll be all about the kinds of angles. Again, like we said last time, less than 90, acute angle. Equal to 90, right angle. More than 90, obtuse angle. These angles, the kinds of angles, come into play when we are talking about triangles. Why? Because we can define what kind of triangle a triangle is based on its angles. Okay? There are 3 different types of triangles when we are trying to distinguish them based on their angles. The first one is the right angle. If you look here, you can see that these 2 lines have made a perfect right angle here, something which is usually notified. It's usually shown to us by this little square here. It shows me that, oh, this is a right angle. These types of triangles have one right angle and 2 more angles that will always be acute. We'll explain why later. An acute triangle has 3 acute angles to it. There's nothing really special about it. It just has 3 acute angles. An obtuse triangle has 1 angle that is obtuse, obviously. It means that it's really big, it's really wide. So this one here is really wide. Since it has an obtuse angle, the other 2 need to be acute. Okay, they need to be acute. Why though? Why do they need to be acute? And this is where angles come into play with triangles. Because in any triangle, if I add up all its angles, they have to make 180 degrees. Here I have made a triangle randomly. I didn't measure anything. I just made it. Just drew 3 lines. Nothing specific. And after measuring their angles, after measuring its angles, what I found was that this angle was 50, this angle was 30, this angle was 100, and if I added them all together, they make 180. And that is true for every single triangle that can exist. So, in the examples that we talked about before, if this is 90, then these two together with this need to make 180. So these two together need to make 90. That means that they are both less than 90, because if one of them is equal to 90, then the other one would have to be equal to 0, and that's impossible. And if you want to understand why better, imagine this. Here's a right angle, right? And here I'm going to make another right angle. So here these lines have formed 2 right angles. I would signify that by placing these little rectangles that we said before. Okay, well, tell me this. Are these 2 lines ever going to meet? This line and this line? If I project them into infinity, will they ever meet? No. The answer is no. They will never meet. And if they never meet, then they can't make a triangle. And that's the reason why if a triangle has a right angle, then the other two need to be acute. They need to be less than 90. That's also why if a triangle has an obtuse angle, then the other two need to be acute. Because again, if one side is more than 90 degrees, then the other two definitely need to be less than 90. Even if you put them together, they need to be less than 90. So if you put them together and they're less than 90, that means that separately they're definitely less than 90. So that'll be all for today. Today was a long one, but we had a lot of ground to cover. So tomorrow we will be doing some examples, and you'll get to see in practice what I told you about the angles of the triangles. We will remember the types of angles and types of triangles, and we'll solve different problems with all of that. Okay? See you guys tomorrow. Bye.